Battery technology. Electric vehicles run on power from advanced lithium-ion battery packs rather than gasoline. These batteries store electricity to send to the traction motor for propulsion, unlike gasoline, which is stored in your car's dyno juice tank. Modern EV batteries can have over 100 kilowatts of capacity, providing hundreds of miles of driving range on just one charge. Replacing gasoline or petrol means that vehicles are cleaner, meaner, and greener. 2. Electric motors. EVs crush gas cars in another key area: performance. Electricity motors have monstrous torque from 0 RPM, which makes these models, like the Tesla Model S Plaid, incredibly impressive. Instant torque from electric motors means brutal off-the-line acceleration, unlike anything gasoline-powered. Many EVs can streak from 0 to 60 in just 3 to 4 seconds. That's legitimately supercar territory. The transmission transfers mechanical power from the electric traction motor to drive the wheels. Electric driving is also incredibly serene and smooth. The lack of engine vibrations and near-silent operation provide a luxury experience. The silence can get so awkward sometimes that you might catch yourself making fake vroom vroom noises out of habit. 3. Regenerative braking. EV motors also function as generators, capturing kinetic energy from braking and sending it back to the battery to top it up on the go. It's like the electric car version of going to the gas station, but instead of pumping fuel, you're pumping the brakes. And with regenerative braking doing some of the stopping work, you may never have to visit the repair shop for new brake pads again. Those things will probably last until the explosive death of the universe. This innovative regenerative braking system isn't just a novelty. It provides a huge boost to overall efficiency and driving range. By harvesting energy that would otherwise be lost as heat and friction, regenerative braking can extend an EV's range by up to 20% in city driving conditions with frequent braking. Rather than wasting that kinetic energy, it gets fed right back into the battery pack. It's the ultimate energy recycling for maximum miles. 4. Charging infrastructure. To recharge, EVs can conveniently plug into electrical outlets just like traditional gas cars pull up to the pump. There are two main types of chargers: AC and DC chargers, each with their own speeds. These are the slow Level 1 and Level 2 chargers found at home or public charging stations. Using a standard 120-volt household outlet, Level 1 provides around 3 to 5 miles of range per hour of charging. The faster Level 2 240-volt chargers can add up to 25 miles of range per hour. But for rapid-fire charging on long road trips, you'll want a DC fast charger. These specialized high-powered stations can zap batteries from 10 to 80% in just 15 to 30 minutes, adding over 200 miles of range in the time it takes to grab a snack. Just like gas cars have different filler ports, EVs also have different charging ports and connectors depending on the automaker. Tesla uses their proprietary connector only compatible with their supercharger network. While most other EVs from Ford, Hyundai, Porsche, and others use the universal J1772 charging port for AC charging and the CCS combo port for DC fast charging. Whether plugging into a home AC charging setup or pulling up to a bank of DC fast chargers, refueling your EV is becoming as simple as gassing up a conventional car. Charging networks with chargers as ubiquitous as gas stations are rapidly expanding to enable long-distance electric travel. Just pull up, plug in, grab a snack, or check your phone, and you're topped up and ready to go in practically no time at all. 5. Range. The latest EVs can travel over 300 miles on a single charge before needing to plug back in. Models like the Lucid Air Dream Edition and Tesla Model S Long Range can go up to 520 and 405 miles respectively on a full battery. That's more than enough for most daily commutes and trips. Cold weather and driving habits can affect real-world range. But when you need to plug in, the charge port allows the vehicle to connect to an external power supply in order to charge the traction battery pack. Since recharging is easy with AC charging at home or DC fast charging, which provides 100+ miles of range in just 15 to 20 minutes, the growing infrastructure reduces range anxiety. EVs like the Lucid Air Dream Edition and Tesla Model S Plaid are leading the way with ranges over 500 miles, while startup Rivian's R1T truck can travel over 300 miles on a single charge. 6. Performance. When it comes to straight-line speed and acceleration, electric vehicles simply blow the doors off their gas-powered competitors. Electricity motors have monstrous torque from 0 RPM, with Tesla's tri-motor setup being one of the most insane examples. meaning some EVs can rocket from 0 to 60 miles an hour in as little as 2 to 3 seconds. That's legitimately supercar territory. The Lucid Air Dream Edition does 0 to 60 in 2.5 seconds, while the Rimac Nevera hits 60 in a scarcely believable 1.85 seconds, thanks to its 4 electric motors. To put that in perspective, the Lucid Air is faster off the line than a $3 million Bugatti Chiron that tops out at 2.4 seconds for 0 to 60. And the Rimac Nevera? It would completely smoke luxury icons like the Ferrari SF90 Straydale and the Lamborghini Aventador SVJ in a straight drag race. EVs are rewriting the rules of performance with their relentless, never-ending torque delivery. Even affordable electric cars like the Hyundai Ioniq 5 and Kia EV6 can embarrass muscle cars and sports sedans away from the spotlight. 7. Energy efficiency. Not only are EVs ultra-quick, they're also far more energy efficient than internal combustion engines. Their MPGe ratings can top 120. For example, the Lucid Air has an EPA rating of 131 mpge, while the Tesla Model 3 Long Range is rated at 132 mpge. Less wasted energy going to fuel costs means much cheaper operating expenses over the life of an EV. This unit manages the flow of electrical energy delivered by the traction battery, controlling the speed of the electric traction motor and the torque it produces. As we explored before, at the core of the EV is the battery pack, a sophisticated lithium-ion battery storing electricity to power the vehicle's motor. Thermal management systems keep temperatures optimal. This system maintains a proper operating temperature range of the engine, electric motor, power electronics, and other components. 8. Smart features. EVs are also packed with cutting-edge smart tech no gas car can match, like advanced driver assistance systems that can automatically keep the vehicle centered in its lane, adapt cruise control based on traffic conditions, and even change lanes by itself with a tap of the turn signal. Many automakers are pushing the boundaries of self-driving capabilities in their latest electric models. The interior experience is just as futuristic, with many EVs featuring massive digital displays and screens spanning the entire dashboard. These brilliant displays provide crystal clear visualizations of vehicle data, navigation, and infotainment. Advanced autopilot systems combine radar, cameras, and artificial intelligence to enable semi-autonomous driving capabilities. Cars like Tesla's can practically drive themselves on highways, automatically keeping within the lane, changing lanes, and adjusting speed based on traffic. Arrays of smart exterior cameras and sensors also enable incredible self-parking capabilities. Just pull up to a tight spot and let the car's computer take over, automatically steering itself into the parking space. Taking it a step further, some EVs even offer a smart summon mode, where you can remotely call your vehicle from across a parking lot to pick you up at the touch of a button on your smartphone. Through connected apps and digital visualizations, EVs provide real-time feedback on driving efficiency, range impacts, and energy usage. This allows owners to better understand their electric driving habits. Many EVs from brands like Tesla, Mercedes-Benz, Ford, and others truly feel like smartphone-controlled computers on wheels, with their cutting-edge autonomous driving aids and smart tech features. 9. Maintenance. In addition to self-driving tech, EVs require far less maintenance and have fewer breakable parts than gas vehicles. The battery pack is really the only major component that may need replacing after high mileage, typically after 100,000 to 200,000 miles, depending on driving conditions. But unlike combustion engines, EV battery packs just keep on running with minimal upkeep. No engine oil changes, minimal brake wear thanks to regenerative braking, and even over-the-air software updates. Without a traditional internal combustion engine, many of the regular service items like oil changes, tune-ups, and replacing spark plugs or timing belts are completely eliminated. Fun fact, Tesla owners only need to visit a service center if they got a notification from Tesla, and that's only about once every 10,000 to 15,000 miles on average, compared to the recommended 5,000-mile intervals for gas cars. Talk about low maintenance. 10. Environmental impact. Ultimately, a key advantage of EVs is their reduced environmental impact versus polluting internal combustion engines. No direct emissions means much cleaner air quality, plus significantly lower greenhouse gas contributions fueling climate change. And as more electricity generation shifts towards renewable sources like solar and wind, the environmental footprint of driving an EV will continue to shrink towards net zero emissions. Embracing electric vehicles represents one of the most impactful steps individuals can take in the fight against climate change and building a sustainable future for transportation. From advanced battery tech to blistering performance and self-driving capabilities, it's clear electric cars are revolutionizing the driving experience like never before.